says, well, it's done. What you can do is when you shut down a node gracefully, it's, well, say to the system, well, I left, leave the cluster, and then you know that it left, right? The other one is, hey, a node is missing. What should we do? And you can build a mechanism around it. Well, so long away, and now I want to drop it, or a manual intervention.
You use a supervisor for when the node is down, and it says I left.
That's all built into Akka. So what you can do is when you gracefully shut down a node, it can send a cluster leave message to the cluster, and then that will be gossiped around, and then you can. So that's built into Akka. And otherwise, what you can do is monitor it, and when a node went away, it's not available anymore, then manual interventions on that to remove from the cluster. Right, and at that moment, you know for sure, okay, now someone removed it from the cluster and now it's not available anymore. And what happens within Akka is that when you leave a cluster from a node, even though it's running, it can no longer rejoin the cluster again, so it has to go down. And again, do not use YAML serialization.
Can you explain why?
Yeah, because it's slow and it's buggy. If you have a different JDK version, it might not serialize again to the same data on different compile sessions. So yeah, it's really buggy to use that. So you really should use something like JSON serialization, Part2of2 serialization, whatever your take is, but don't use the YAML serialization because in the end there will be a moment that it breaks for you in the most inconvenient way. An observe remove set, which is a little bit harder than the grow only counter. And an observe remove set is called observe remove because you can remove observed elements, which means that if you saw an element in a set, you can remove it. And a naive implementation would be to say, well, okay, I have two data sets like positive negative counter, and for adding I use one data set, and for removing I use the other set. But then when you merge those, you can no longer, if you remove apples from the grocery list, you can no longer add apples again because it's on the removed list. It's no longer possible to add it. So you need a different mechanism, and what they do in Akka is they use something which also compresses your history so that you don't have to carry along all removed elements. So if you look at this setup, in the left you see we have two nodes, node 1 and 2, and they have the same data at this moment, right? A, B, and G are elements of the set, and they are annotated with a version factor. And that's the version factor in which version this element was added to the data set. And a version factor is just like a grow only counter. So every node has its own counter in this vector, in this tuple, and they can only update their own counters. So the current version is 2.1, and element G was added as last. So node 1, they're completely disconnected right now and they carry on, right? Node 1 says, well, I want to remove element A from the list. And it simply does that by removing the element from the list and updating his own counter in the list. So to say, well, I changed something in the list and it's for you to figure out what changed. Node 2 does something else, it just adds element set to the list and updates its own counter. In the red you see that node 1 only updates its own counter and node 2 only updates its own counter. So there are now different versions and we need to merge them. So let's say that node 1 sends its data to node 2 and it needs to be merged. So node 2 receives the data, it looks at the similarities and it will see, well, B and G are still there. But I have an A and you don't send me an A in your list because I removed it. But I see that A was added in version 1.0. So you certainly must have seen that because you have a higher version than the version in which the element was added. So by this, I know that you must have removed the element A. So I remove it from my list. And still I see my own element which I've added and added to the list. And now I'm at version 3.2. So I have the 3, which is from the and the 2 which is my major version. If I send my version back to node 1 sees that B and G is still there, and its new element Z, and can merge that, and then they are at the same version.
Can they update to the same version of the second step? So first we'll remove and become 3.1, and second we'll add and become also 3.1. Is it possible?
No, because this version factor, you can only update your own version. So node 2 has the second number in the tuple,
Okay.
and it may not touch the first number in the tuple because that's from a different node. And with this mechanism, you are certain that the versions always grow up and no one can have conflict because you're only touching your own number.
Okay.
So this is called dot version factor, and this is a mechanism where they compress the data and make it so that I don't have to carry on all the removed data. So there are limitations to Akka. Well, certainly it's eventually consistent, and you have to know that what that means. I mentioned before that every node has the complete data set in memory, so it's not suitable for big data. It transfers the complete data set, so it means something for your traffic. Don't put large entries into your data sets because it will lead to a lot of traffic. And there's no persistence built in. So that means that if your complete cluster goes down and you start one node up, you are completely empty again. So if you want to have some form of persistence, you have to implement that yourself. So now I want to do some live code. We have quarters. And I will manage that easily. This is a very, very simple use case service discovery where we have 2 nodes started. The left one wants to register a service, and then the other one wants to query the service discovery to see, well, is this node, what is in there? So let me start with the current implementation. This is Akka HTTP. What you're looking at, it's not really important to completely grasp what's happening here, but one thing is that I have a path/services, and I can do on the segment. So this is services/foo, where foo is the name I will use later on under name. And I can do a GET request on that. And what it does, I've shown in my slides a bang, right, to send a message. But there's also a pattern in Akka which is called the ask pattern. And with the ask pattern, you simply say, well, I sent this message out, but I expect the message back. And I expect the message back in a certain amount of time. That's why this timeout is there at the top. So what will happen? To this service discovery actor, which we'll look into later, I send this message get. And more specific, get all service instances with this name. And this is a future, which Laurent talked about. When this future completes successfully, I want to carry on with this code. And what that does, it just matches, this is Scala matching on the result. So it will send a message back, right? So it's messaging, it's still the same. So I send the message get, it will be processed, and I will get back the message result. I match on that, I take out S, and S is the result I got from the actor, and I complete this request with the data. And the same is more or less for the post. So then, this is where all the logic is, the service discovery actor. And this is a very unique implementation. It's just using a simple set, an in-memory set, and when I register, I add an element to the set, right? So I just say services in Scala, the default is to use immutable data types. So just adding services, like what's in the selected part, adding a service to my service set will render me a new set. And if I don't assign it to my variable service, it will return away. So I have to assign it to this service. But this is fine within my actor because I'm in a boundary where I'm the only one currently running code, right? There's no possibility for multiple threads mutating the same reference service. And when I've done that, what I told you before, you have a mechanism to request the sender. I send a message to him back, well, I updated something. And for the other one, Laurent gave a little introduction about using maps and filters. Scala is really a functional language, so you can use all those concepts from functional programming within Scala. And what I do here is just very naive. On the complete set, I loop over all elements and filter out every element which has the name, which is exactly the same as was specified when I got my request, the get message. This will give me a smaller set, and this set will be sent back in the result message to the sender. So just to show you, I will start. So I start two JVMs with the application running, and maybe your gut already tells you that they're completely different, because now they're running on two ports, 8080 and 8081. When I post something with HTTP pipe, I post service to /services, which you've seen in the Akka HTTP part, right, with the foo part, which is my service here. And I say, well, this service is running on host different and port 9878. So I can now query the same URL in the get. By the way, I left with posting HTTP py, if you don't know it. If you put host is different and port, it will create a JSON object for you and post that to the service. So you don't have to write your own JSON object in a file and with curl use some data mangling to post it there. HTTP py will do that for you. So now I will do a GET request on the service. And it will show me, well, here's my different service which I posted earlier. And now, very obvious that when I ask the other JVM for this service, it will give me an empty list, right? So let's look at what I have to do to create a more connected, so that I, next step, can create two servers, just like just right now. But they will be interconnected with distributed data. So the first thing you need is the replicator, right? So let's put the replicator in the code. I can get the replicator from the distributed data extensions and get the replicator from there. And if you look at the type here, Scala is all about types, really type. Even though you don't see the types there, which we would have seen with Java. It's an actor ref. An actor ref, you have a reference to an actor. That's the only way to interact with an actor, by sending messages to an actor ref, and it will go to the actor. And on the line below, you see this cluster node. And as I explained in the observe removed set, you need some knowledge to know, well, every node has its own counter for the vector version, right? So I need some information about my node. That's why I use this cluster information and have this node here. But you can ignore this. So I have to interact with the replicator. And the replicator will give me access to every data set I have. But I have to tell the replicator, well, I just want to access a certain data set. And in this example, I will use an observe remove set, and I will create a key for it. What I say here, well, this is a key I will send to the replicator, so that it knows, okay, I can find your data type under this key. You can look at it as a big map, right? So there are different data types, all structured under a map. So they can use this key to look the right data structure for you. And within the observe remove set, there are services. And service is just a container with a host and port and so now I will first look at retrieving data from this data set. So at this moment we have bottom. We used to have a situation where we only have this one get scenario where we can immediately, without blocking, just operate on our set and get the result and send it back. But as I've told, interacting with the replicator is asynchronous, so we need more than just this filter. So I will remove this one. First of all, I will get just the request as I've got before. And what I do is I say to the replicator, well, I want some data from you. And more specific, I want the data which you can find under this key, right? Because I specified before, the services. And then I can specify the consistency, the read consistency. And in this case, I only want to read from my local machine, because for service discovery it doesn't matter if it's any consistency for it. It's just, I want data which you have, and that's fine for me. But you can also specify, well, I want you to read from 2 nodes from a majority or what you've seen. And then this might puzzle you a little bit, is you can send some context. Because this is completely asynchronous, if I send a message to it and I don't send my context with it, then the context is lost. Right? When I get my reply, I don't have any context to base my result on. So what I can do, I have a container here, which I can specify any data type I like, put data in there, and send it along. And what happens, let's see in the next case, is when I get a result back, it will also not only give me it will give me a success. It will tell me for which key this is a success. Because you can imagine the replicator can operate for all keys, and you can do that in your own actor, can operate on multiple data types. I wouldn't recommend that to have one actor only operate for one data type, but the replicator will tell you, well, here's my result for this data key. And by the way, here, and you see that in the sum part, so this is in the last part, you told me your context and here you have it back again. But that's a mechanism to have your context back. And I need this because I need to know the sender, right, who asked me this question. And I also need to filter out the set and only get back the names of where the services is the names were specified in your request. So what you do on the result, you retrieve, and this is a little bit of syntactic noise because you have to do, Akka for Scala needs to know the data type to operate on. There you have to specify your service key so that the thing you've got back, when you look at the data type, it knows now that it's an OR set of service. From that set I can get the elements and do my filter actions so that I have the data. If you don't completely understand, there's no problem, you can look it up later, but this is how you can operate on it. And I forgot to mention, and it's really important, you can also do that with Java, right? Akka is completely compatible and you can write everything with Java. So if you're logged in Java, no problem, you can still use this. I can get 2 messages back on my GET request. One is the success, as I talked about, but the other one is that it's not found. So in the key it has a name, but if the element does not exist, the data type does not exist yet, I will get back the not found exception. This can only occur when there's nothing written to it yet. So what I do here, I have to simply send an empty set back to the sender. So we're almost there. We need to register our data, right? So the register used to be just one simple call, but now it's asynchronous with the callback. So the registration is a little bit same like the GET request, right? So what you see here is I want to update, dear replicator, please update this for me, and this update this service, this data key. If you don't have any data for this one, please initialize it this way. And I want to have this consistency level. So again, this is only write local, but you can choose this. And be so kind to give me my context back when you're done. And the thing you've done here, and nowadays Java also has lambda functions. This is a function because you send a message to the replicator and you won't get anything back. You just tell the replicator, well, on this data type, I want you to perform this operation. And what I do here is, okay, it will give me back the OR set in a function, but the replicator will perform this operation. So on this set, I just want to add this service. And notice that I'm not assigning to any value because I mentioned before that I have to assign it to a different value to not lose it. But this is a function. This function will result in a new set, and that will be assigned for you to the new set. It may sound a little bit difficult, but once you understand it, it makes more sense. But just, well, you post a function to it to mutate the data. That's the takeaway. And then again, you get back your actions, right? So the update might be successful. And then we have two possible failures. One I already talked about, the update timeout failure, right? If you said write to all nodes and one node is not available, then you will get a timeout. The other one is a modification failure, and that will happen when I say throw new exception, right? If the function throws an exception, then you will get a modification failure message. So we're almost done. Just get rid of this empty lines. The old service. So one thing we need to do. Previously I started the application just as a single standalone application, but now I want them to create a cluster for me. So I need a different provider which says, well, now you don't only look at your local system, but go broader and just try to connect with the cluster. And you also see, I lied a little bit because I need to do multiple things, but also specify seed nodes, so that, well, it's common sense, right? Common in a cluster where you just specify, well, these are the seed nodes. When you start up, just start talking to them, and then you can connect to the cluster. So that's what I've done here. I just specify 2 seed nodes on my local host. And that's basically it. So now I'll start the example again, and it will compile my code. And what you see is a lot more of logging than you saw before, because now it's doing some network negotiation, right? So it's looking for the seed nodes, and in the end it only finds itself. And because it's the first seed node, it can promote itself to up, and then it is a cluster. So I have now a cluster of 1, and now I add the other node. And if you look at the top, then you already see something happening there, and it will promote the other nodes up. So now I have a cluster with 2 nodes, and if I repeat my post to the first node, and certainly I can get the information from that node because it's still the same node, right? So here's my data. But now, if I go to the other node and ask data, it's also there. So now the data is propagated in an eventually consistent way using the distributed data from Akka from one node to the other node. And I can operate both nodes, drop one node, stop one node, and continue on, join again. So that's basically my presentation to show you what distributed data is, what the CRDT is in theory, how it's implemented in Akka, and how you can do it yourself to write an application. Are there any questions? Please.
Yeah, so typically for business features, the product owner will think of many different types of queries that you want to fire on the database. How would you approach this here? Because it seems like one node should handle one type of query. Is that what I'm getting here?
The data is completely propagated to all nodes. So if you want to get information from it, and you can pick any node and do your logic there. So you retrieve the set. If it's just one big set, then you can do anything you like on that set or on that map or whatever data type you choose.
So in that case switch that you had, you just add another filter for it as well.
Yes, exactly. So in this actor, I have this register action, but I could also specify a query action. And like I did here, this is just a get action, right? And I can also say, well, I want a query on host or whatever you like. And there you have all your actions within this filter or stuff like, because this will give you just a set with the services so you can operate anything what you like. And remember that every node has the same data. That's really important.
Yeah, you mentioned that one of the downsides of doing Akka was that you keep your messages small. And when you talk about service discovery and micro services way when I make updated to all the services, is that still small in your eyes, or would that be next kind of on the edge of what's possible?
Yeah, well, it depends how big your message in the end is, right? What kind of
yeah, that's what I'm asking, like,
so
what do you mean with big?
I don't have a number for you. So what you have to do is just try it out, just do a performance test on your system and see how it performs. Just see, well, if I serialize my data using a protobuf, it will be this big. Is there any way to compress that again and stuff like that? There are all, but make sure that you're not sending really big data, or if you do, that you know what you're doing, that it's all sent over data every time, on every dozen. Another question?
Do you need to have nodes within the same cluster to be the same? Or they can have different actor systems and we'll be able to replicate actors by just sector F. You understand?
No, I don't.
You have one actor system and you replicated it fully on different nodes,
yeah.
right? So can you have different actor systems, but these different actor systems will have actors with same actor F.
So what you can do is you can make subsets, right? So what's possible is to say, well, every node has a specific role, and only to that role you will use this replicator. So that if you have a complete cluster, then not every node in the cluster participates in the replicator and is replicating the data. But if you want to replicate data, the whole set is replicated.
Okay.
Does that make sense?
Yeah.
Any other questions?
Do you have more use case for that? For using Akka with
yeah, I think a basket, a shopping basket, right? Something which can be fairly, where multiple people are working on the same shopping basket. The grocery list, something like service discovery, everything where you can maybe at one point be disconnected. Google Docs, for instance, is using CRDTs for their merging of the documents because you don't have any conflicts on your Google documents, right? They're also always mergeable. So those are all the use cases.
yeah, sure. A database that's logical, but Google Docs makes sense.
Okay, so if there are no further questions, I wish you all a good night.
Yep.